Okay, we can start now. So, very good morning, and then welcome you all on Sunday morning. I'm sure you'll be getting bombarded with plenty of sessions from everywhere because of the online programs that are getting conducted in this scenario. So here today, I would like to initiate the session on SQA and software testing, because both are slightly different in nature. The software quality assurance and software testing. The software quality assurance, if you call it from a company perspective, it's an overall stuff to ensure whatever being delivered from the company is of a specific quality. For example, what is the major difference between a CMM company and a non-standard company? Because the moment we say it's a standard company, we are now seeing in the products and all ISIC, the kind of ISO standard kind of thing, which they will be able to produce repeatable results. That is, once you deliver something, the next time also they can expect the same quality of delivery from you. So that confidence as well as that repetitiveness of the delivery quality will be assessed by means of this kind of standards called CMM, TMM. TMM is a capability maturity model. Today, we have gone into capability maturity model integrated also. And then we have test maturity model, and more or less we have Six Sigma, and we have ISO. So we have 4 or 5 of these kind of standards, which is being followed by various industries. ISO is mainly followed by the manufacturing industries as well as product companies, whereas CMM and Six Sigma are more predominantly using companies. So there are certain base levels which we need to verify the process, check the process, and so on. So they need to have a specific team, which is called the SQA team. That's called Software Quality Assurance Team, which will ensure, are you following the process? If you're getting a requirement, are you checking it? If you're writing something, code, are you checking the code? Whether the code is of required quality or not. Are you doing some testing? Are you following all the testing processes? Basically, they will be verifying each and every step to ensure you follow the standards so that the delivery will be of a required quality. That is software quality assurance, which has a wide range of application as well as opportunity for our students in industry. So now they are going for plenty of auditors. They call the SQA audits. They need to have a checklist and ensure all the processes are being followed. For doing this, they need to understand what is software quality assurance. Because first they need to understand some basics like SDLC, that is software development lifecycle. What are the key areas in SDLC? What are the tools being used? It's a very long history, or I would say a long list of knowledge that we need to gain to understand all those things in detail. So one particular sector, I would say if a company is comprised of 100% of resources, normally 25 to 30% will constitute for testing. and some 20% will constitute for project management, and then some 25% will be constituting for development, and then rest will be 5 to 10% will go for this quality process. So if you take an overall SDFC as a percentage, an effort, nearly 30 to 35% of the effort being spent on quality for any software being developed. And for coding, it is only 19 to 20% of effort is being used. So this is the fact whenever you get recruited in a company, whether as a intern or basically a initial system analyst kind of thing, because 30% of the company revenue comes from your testing area. You take Infosys, take Wipro or any other company, they get their revenue of 30 to 35% from testing engagements, what they have. So it's a very, very important part in the software. And the more importantly, you have enough number of on-site opportunities in testing engagement, because the reason is the test data which is being done by the customer who is in outside India or something, they are basically very confidential ones. They don't want those test data to be provided to any other, even their own vendors. So normally, testers travel on site, go to their places, sit with their business units, understand the business scenario much more clearly, and do the testing and then come back. So in my career, I would say in around 25 years of testing, we would have at least sent around 150 people to UK, to US to do the testing, out of which in UK, around 30 people have got PR, permanent residency. That is the nature and the, what I would say, the opportunity that is available in the testing area. So now we come to software testing. So this is at the overall company level, we have a software quality assurance. And software testing is more or less predominantly with respect to a single project. What is the type of the project? What are the different types of testing we have to do? Starting from your requirements testing, functional testing, system integration testing, performance testing, test automation, security testing, and then business acceptance testing, then load testing, then usability testing. There are around nearly 30 to 40 types of testing that we used to perform in a single application based on the, I would say, the need of the industry today. So in these kind of situations, so there is a very bright future who are going to take SQA or as a software tester. And today the buzzword here is automation, where they divide into two different types. One is the Selenium based automation, and then RPA, remote process automation. What we call the RPA is also there. Robotic process automation is there. So we are going into bots and stuff like that. And there are plenty of platforms which has come to aid this kind of automation. So in this session will be there for 8 to 10 sessions. We'll completely cover what is software quality assurance in a company one by one, and what is the fundamentals and basics of software testing except software automation, because a separate group or a session is being conducted on Selenium based test automation by Prasanna. So I don't want to combine that with just the complete fundamentals of software testing, why we are doing different types of testing and what is the use for that and why we need to do that, what are the methodology and then techniques used to do the software testing, how do you write test cases. We'll get into detail as if you are attending a testing training company. So that's the purpose of having this kind of sessions, so that instead of students going to multiple training centers and companies, we are here to provide you the same quality of training to you, including the assessments on a regular basis, so that you can actually get all those details from the experts who are available with us. Because people who are trainers are not really very good experts. They know how to teach very well. The problem with the people who are doing is they don't know how to teach. So we are trying to strike a balance between these two and then bring the best for you, so that you will be able to understand Selenium completely if you are attending the session, and you should have a very fairly good knowledge in software testing when you are taken this session. So that's the introduction from my side. Then we have a recorded lecture series 1 which will be played by Vinod, and I'll be available after that for questions. Then we can discuss whatever is required, and then we can take it forward. Okay, Vinod, I would request you to play the session now. Hi, good morning everyone. So I welcome you to the session of software quality assurance and software testing. And today is going to be an introductory session, so where we will go into detail about what is software quality assurance and what is software testing, and also we will cover what the student will get on taking up this course, because this course is going to be a series which at least we will have some 8 to 10 sessions in which we will cover in detail about software quality assurance as well as software testing in detail, and more importantly you will also understand what are the opportunities that you will get in the industries while you're completing your degree programs, whether you can be in the software quality arena as a quality auditors, process mentors, process designers, and so on. And similarly, in terms of quality testing, like software testers, whether it can be a functional tester, automation tester, performance tester, security tester. There are multiple opportunities in software testing because software testing commands nearly 35% of the SDLC effort while you're doing a software, because the coding effort is around 19%, whereas the quality effort is around 35% of the entire SDLC process. That we will cover in detail. So now I would get into the presentation mode, and please feel free to ask me any doubts and clarification once the session is completed. So the way we have structured this session is we will take up this lecture session for around some 45 minutes, and 15 minutes we will open the floor for the questions. And also at the end of each session we will provide you with 10 to 20 questions which are more relevant to industry and what the industry people will ask. That will come as a multiple choice question for you in your mail, so that you can click and then you can answer those questions, and self-evaluation will be done. So in a period of time when you have completed 10 sessions, I would say, you would have at least around 200 questions on software quality assurance and software testing, which is going to help you very much in your career perspective. Now I'll get into the presentation. Okay, now I'm sharing the screen for you. So first we will take up what is software quality assurance and what is software testing. So software quality assurance is fundamentally ensuring quality of the deliverable. So we might have multiple ways in which deliveries are made. For example, there are two areas most of the software development happens. One is software as a service, which is service delivery, and the other one is a product development. Services are all whatever major software companies are doing here, like your Infosys, Wipros, and then Accentures, and then TCS, Tech Mahindra. They are doing projects for outside companies where the application is conceived by the vendors, and I would say the key companies, and we are developing that software according to their specification and then delivering it to them. So while delivering to them, the key important aspect is the quality of the deliverable, which has to be maintained, monitored, and reported at all stages, right? From whether it may be in the design stage or it may be in the development stage, testing stage, or maintenance stage. So all these things has to be completely monitored and managed. So that is why we ensure quality. In layman terms, what you have to say is, for example, if you're developing a car in an assembly line, if you say, if you're developing 100 cars, all 100 cars would be the same. There cannot be any differences in the car coming out from the assembly line. So the main purpose of having this SQA is to create those kind of situations in software delivery, because a lot of human interaction is involved in this, because each developer is not the same, each tester is not the same. So there's a higher amount of possibility that quality may change. That is why we put into a lot of process, so that everyone follows the process so that they can give a standard quality. That's what ensuring quality. And the second thing is, the SQA covers the entire software development lifecycle, because the software development lifecycle consists of 5 different parts, which you will see later, starting from your gathering of requirements to the maintenance and sustenance of the product. So the SQA covers all the areas It's a integrated, I would say, a very comprehensive delivery coverage, right from your requirements to the delivery of the product or a service. That covers the entire SDLC, and it is completely measured. So the key important thing of having an SQA is it should be measurable. How do you measure that? So there are multiple ways in which we measure this, and there are multiple models available for that, which we say it as a CMM model is there, and then test maturity model is there, Six Sigma is there, ISO is there. ISO is mostly used in manufacturing industries, but especially pertaining to software industry, we have a CMM, we have a Six Sigma. These are the two prominent things which we use for the measured results. And we will get into detail into each one of them. So how CMM works, how Six Sigma works, what are the measurable activities that we will capture, and what are the standards that we have in the industry today. All these things will be covered in this series of lecture. And then, as I told you, the standards. We'll focus more on CMM and then Six Sigma. CMM we'll try both, because CMM I has come now, which is CMM integrated, which has also taking into account of the resource component of the processes. That's why it's called CMM integrated. So overall in SQA we'll be covering these things, and software testing is more or less conforming to requirements for a particular feature or a function of a software or a software by itself. So basically, to put in a very simple thing, if you want to develop something, you have to check whether it is working properly. Whether you want to check if it's working properly, you need to see what are the features of that. So it should provide this, that, and then basically the key deliverables or the key, I would say, outcomes or goals of developing that particular application or a product has to be met. To confirm those features, we have multiple types of testings. So I can recall some of the testings. First, it starts with your system testing, functional testing, integration testing, then system integration testing, then acceptance testing, then you give business acceptance testing. These are normal functional testing types. Then other testings, we have something called NFR, which is non-functional requirement testing, which is called performance testing, security testing, load testing, and then what you call usability testing. And then there are many more testings. We have around 40 types of testing which are being done rigorously in each of the applications getting delivered. It depends upon the usage of the application. For example, if you are developing a finance application, then obviously the testing has to be much more rigid, because you can't have any compromise in the quality in terms of your banking or financial applications. So depending upon the type of application, the number of tests that is being performed as well as the coverage that is being done will increase. Then tools and techniques, because there are multiple tools which has come for testing. Because if you take testing as a whole, so you have to write test cases first. So you have to understand the requirement documents first, and the test cases has to be basically divided into multiple types, whether it's a simple, medium, or complex kind of thing. So again, there is a standard why we call test case as a simple test case, or a medium test case, or a complex test case. So varying all these things, there are multiple types of testing and multiple tools which are available and techniques which are available, which we will go in detail when we come to the software testing list. And for doing the testing, we have two key models today, which is the V model was very predominant in the earlier phases of software development, and also basically it's called top-down approach model, where because there are two scenarios I would like to tell you. So the one thing is you completely develop the application, finish the application, and then give it to testing. And then they test the complete application at once, and then the finally the product come for release. So that is the happening in the previous times. And now what happens is the entire thing has become agile, which means the product is being developed feature by feature. Today you'll have one feature, and tomorrow we'll have some other feature will be there, and the next day we'll have one more feature. So feature by feature will get tested. So that is called scrums. That's what we will cover in detail about the agile model. So in terms of software testing, we'll understand the basics of software testing, different types of software testing, and what are the tools and techniques used in software testing, and the multiple models in which the software testing is deployed or employed kind of thing. Now I'll move on to the next thing. So what you will understand from this course? As I have reiterated, you will understand the software development life cycle, you will understand the capability maturity model, you will understand the test maturity model, you will understand the concept of Six Sigma. And also what I would like to do is, while doing this, we will take some sort of role play among the students or the listeners of this webinar. So we can pick up some role play kind of thing, because CMM and TMM has multiple what you call it as a KPIs, which is key performance area. So we can identify some 8 or 10 people and then ask them to play key role as the areas. So then we will come to know how important is each of the areas while coming in with processes. You will look at the work that is going into the software quality assurance and what is the to that in terms of tools. Maybe we can provide access to 1 or 2 tools for the students to play around. That means they can come back with their findings and then basically we can evaluate that. So all these things will give a feel that you are really doing that as a job rather than learning it as a course. So it's useful for you while interview or get into a company to do that. Then software testing fundamentals. So why we need software testing, and then what are the different ways in which you can do software testing. So while you write and then you actually take the requirement documents and then convert that into test scenarios and the testing. There are multiple ways of doing that we will cover those testing fundamentals in this session. And then there are plenty of software testing tools available. For example, HP, if you take HP has a quality center which takes to do the requirement tracing. Multiple things when we get into testing tools. For example, in the software testing fundamentals, we will also explain you, for example, how we do the requirement tracing, how we ensure that each and every features and functionalities that is developed is being tested. So that is the coverage metrics. The coverage metrics should always be more than 95% or more. So to the software product to pass the QC section. So those things we will explain in detail. And automation tools. Some of the processes, especially in testing, can be clearly automated. Most probably, Selenium is a parallel session which is going on, which is also very, I would say, attractive and friendly with the market today. But this, we will cover the overall automation tools and basic functionality and why we need automation, first of all, and in which kind of scenario we need automation. So those kind of fundamental basic things will be covered here, because one of the key inputs that we keep getting among the recruiters as well as the technical recruiters are, they are good in tools, but they don't know the basics in terms of why it is being done. So we will particularly focus on those areas and then make sure you understand the real necessity and need why we are doing this. So, and finally, are you willing to create your career as an SQA and software tester? What are the benefits of doing that? How stable will be your job? What would be the salary package? And what is your growth potential? Is there any on-site probability, on-site opportunity, which is more? All these things we will provide you as a career guidance in this kind of course. So that is what we will do it in this slide. And then we're coming into basic, because I don't want to take much time in terms of getting into basic. There are a volume of materials available for you to browse through in detail, because our focus is mostly on the SQA and software testing. So any additional things which you are having interest in terms of getting into depth, you can do it by yourself. And here the fundamental, I would say the minimum criteria that is required to understand SQA That's what I have listed here, because SDLC, which is Software Development Life Cycle. I think you would have covered it in your, I would say, your curriculum, but we will provide you an industrial approach for this. I will take a small example. So if a company X want to provide a work to you to develop a software, what are the things you will do? First of all, they have to provide you with the requirement document. They have to pen down all the requirements, or they have to write it in a piece of paper, or they can use a tool like UML to provide the requirements and provide it to you. You have to read that, understand that. We have to have an interactive session between the business owner and your team to understand. And then basically after understanding that, you will come to an understanding what is the technology that you are going to use to develop this, because we need to see whether the application is going to be scalable or application is going to be static and which is going to be used in multiple geographies. So many other factors will come into play in terms of requirements. Based on that, and also cost is an important factor. So based on that, you choose the use the technology which is going to be done, whether you are using Java, whether you're using Microsoft-based thing, or you're using any scripts, JavaScript-based development medium. So you will come to an understanding of what is the technology being used there. And then once the technology is arrived and there is a basic understanding on the requirement, then we get into the design phase. Design phase is very, very critical. In the subsequent slides, you will find the amount of effort that goes into the requirement phase will definitely bring down your cost to a larger extent when you see a completed product. So you have to think more and then spend a good amount of time in understanding and analyzing the requirement, especially in the design area. So we need to find which type of design is required. So how we are going to do holistic design. So you need to divide become a component-based or microservices-based design, which is more predominant today, so that it can be used in multiple areas. One time you design and develop it and can be utilized in multiple areas in the course of the development of the application. So that we need to focus on the designing stage. Once the design is completed, then even in the design, there is a high-level design, low-level design, technical design. There are three types of designs which is there. So high-level design will go in terms of what are the major functionalities and features available. And then in terms of a low-level design, we break them into multiple functions, or I would say objects or functions, because objects may be inside the function, mostly in the functions. So now the way the design thinking concept has influenced the software world is to make the design in a more holistic way, where it is mainly used as a capsule so that it can be used in multiple areas. So that is what the architect will be much more interested, and architect should ensure the performance of the application, scalability of the application, load of the application, as well as usability of the application. Because these are the four pillars, I would say, in terms of the design concept. So that will be covered, need to be covered in detail. So we'll get into that. And then the different development models. As I told you, one is a top-down approach where you completely do the development and then do the testing and then go for live. The other is basically it is agile model where you do incremental development. So feature by feature we keep on adding, and there is a strong adoption of this model in today's industry, where we have Scrum Masters, we have Scrums, and we call them as storyboards. So the use cases are now called as storyboards, and each storyboard will have 20 stories or even 30 stories that they will group it into a Scrum, and they will develop 20 features and then go live. Then they will take up another 10 or 15 features and they will go live. So that application will, I would say, incrementally get into live, and then they will have a 4-year or 5-year plan for that. So that will be in sync with their business plan, so that how it is going to generate revenue or money from them or for them also. That also we'll get into detail. And then the engagement models. For example, we have plenty of software companies today, big, small, as well as startups, and then huge, large companies stuff. So how they are working. One is basically it's a project mode where you provide them with the resources, and then that resources is completely earmarked only for a specific client, and they pay for the resources on an hourly basis. Whatever dollar, $25, $30, $10, $12, whatever it is, depending upon the technology, work, as well as the experience of the person. So in this model, what really happens is the onus is completely on the company which is providing the project. So that the efficiency of the team here is more or less controlled by the provider, that is the requirement provider. So the vendor companies, companies which are providing services, has to ensure the resources are present all the day, they are doing the deliverables as required, and we have a benchmark. For example, if it is a testing part, the person can write around 30 simple test cases, or 12 or 13 medium level test cases, or around 25 to 30 simple level test cases. That's called the productivity of the person. So the service providers should ensure the productivity and then availability of the person. And more or less others, what you call the soft factors like your communication and your meeting attendance, so many other things are there. That is one model. The second model is you do it in the center of excellence, because larger companies now comes and set up center of excellence, which means they will work in a specific domain. For example, if you're working in a Microsoft accepted Dynamics kind of thing, then you will become an expert in a period of time while working on the products. So you will be a closed group of people, completely secured, and more or less the process followed in their native company has to be followed by the service provider also. There are some checklists like 10-15 activities, which whatever the requirement or the company which is providing projects follows, has to be followed by the service provider too, even a separate facility. So next comes the offshore facility. So we create a separate facility, we mimic the infrastructure which they has in their own native development environment or a testing environment, the process followed by the people, and then basically the tickets as well as incidences, as well as your maintenance, sustenance, everything has to be in line with what customer you're doing. So that comes under COA and OF model. So these are the engagement models we work: project model, resource model, center of excellence, offshore facility, and there is a large level of because the way you are doing center of excellence is you'll be generating a lot of assets with respect to a particular technology or a particular domain. Or for example, if I'm working for a travel company, I'm taking it as an example. So a travel company has, if you're developing a software for a travel company, you need to be well versed with 3 or 4 things. One is called Amadeus. Amadeus is a common reservation system being used by all the flights across the world. That's a common reservation system. So anyone who is going to be in that industry need to know in and out about Amadeus communication. What does Amadeus sense? What does Amadeus take in? So how you going to integrate your application to Amadeus? So these are some of the industry or a vector, I would call a vertical based knowledge that you'll be generating while you're working in a COA. Similarly, if you're working in a pharma company, then there is again certain kind of Swift codes are there. So protocols, that is IS9, which is a standard protocol for medical insurance. So this kind of thing, you'll become an expert. So that is where you call it as a domain experience. So if you have worked on a pharma company-based software CE, then definitely you will get an opportunity to work in a company where they are having those kind of setup. So that is why you are preferred person when compared to any other person if you have worked on a COE. So that we will cover in detail. Then multiple process models. It's a huge area. So we will try to cover as much as possible. And the required skills, your technical skills, what are the technical skills that you require to perform your job as a SQA or a software tester. For example, coding is also very much important, even though you're doing manual testing. The first thing in this is basically communication. The fundamental is, the basics is you need to be able to understand the requirements from the customer, and you should be able to communicate your understanding and your clarification to your customer vocally as well as written communication. So sometimes when we look into a written communication of certain people from the industry, we will not be able to understand anything. So that should not be, it should be quite simple, clear, and you should be able to convey what you're thinking in a very, very, in terms of good clarity. So the soft skills part, your communication is very important, written as well as your oral communication. That again, the third thing is from the personal side is the maturity level, in the sense that, for example, because you need to work as a team in any of these kind of environments. You're not doing your own business, because it's a kind of a team effort, team being collaborated by the customer as well as by the service provider, by the vendor. Sometimes you need to work with multiple teams from multiple companies. So you need to have the team spirit, and then the a team concept. I think there is a separate session required to understand the team spirit, how the team spirit works. So what are the things you need to give up while you're working as a team? What are the skills that you need to acquire while working as a team? So that's very, very critical. I would say when you're going to be a successful developer or a tester, these things will definitely contribute to 35% in terms of your, I would say, success story share. 35% it will contribute. Only 60% will be your technical skills. 35% you will be judged based on your capabilities in terms of your soft skills. Then in technical skills, you need a Java knowledge or basically a C plus C knowledge, because any tools, automation tools today are employing any of these things. The additional thing will be a good knowledge in the JavaScript. And today Python is also coming very, very popular, because most of the analytics applications that are coming up today are using Python for. So I would say be comfortable with Java basics, Java, Python, as well as some C standards. If you are comfortable in these three things, I think you will not have any difficulty in getting into any of these companies together. So this I wanted to explain you in detail. So why we need SQA. So now you can see multiple stages what I have told here. There's requirement stage is there, design stage is there, coding stage is there, testing stage is there. System test is basically you are developing some application, and that application will talk to multiple applications worldwide. So for example, if you are developing a travel portal, like your Make My Trip is not standalone. Make My Trip is just the front end. Make My Trip talks with Amadeus to pull in all the inventories for the flights. So when you're doing some sort of development, we should also ensure those parts are also getting tested. And in some cases, you will have nearly around 5-6 technology together to be tested alone. So that is called system testing or system integration testing. So then if you see this, so normally in the logarithmic scale, so the cost to fix a defect is nearly 80 times more when you are doing it at the end. So at the requirement stage, it's just 1%. Design stage, 1.5%. Coding stage, 2%. Then 4%. Then 13%. Then you have 80 to 130%. So that is why everyone is focusing on the SQA activity. This can be achieved. For example, if you don't do this quality or testing together, then you will end up in spending millions of dollars, especially in fixing the defects. And also in terms of work, the effort that is required to fix a defect at the end of the application is nearly 4 to 5 times more. I'll explain why. So you are adding feature by feature and then doing the testing. When you do at the end and you find a major defect at the end or a flaw at the end, you will not know where the defect has occurred. Whether it has occurred in the code, whether it has occurred in the system, it has got hosted, whether it has occurred in the DB, whether it has occurred in the application server. So wherever it is, you will not be able to figure that out. So you have to do a complete regression test, which means I will give a math in terms of, for example, if you are having a 10 people months projects, obviously 30%, 25 to 30% will be a testing effort, which is basically 3 people months. 3 people months is nearly, to Indian standard, is around $10,000 of rupees, $10,000, which normally a US company or UK company pays to Indian companies to, because a people month is nearly around 8 hours per day into 20 days, 160 hours is called people month. So for each hour, even if you put $25, they will be paying at least around $3,000 to $4,000 per person, depending upon the profile of the person. So effort means they are spending around $10,000 for a very small project for testing. And if they find the defect at the beginning, they are safe. And if they find the defect at the end, they need to spend another $30,000 to fix the defect and again basically test it again. So that is the criticality. It's not only the cost, but the time to market. Because today, delivering the product in time to the market is very, very important. For example, a lot of offers are coming. Nowadays, everything has become online. You would have seen that in today's situation, I would say 80% has become online. Your shopping has become online. Your travel has become online. Your banking has become online. Even your procurement of groceries has become online. Everything has become online. So you will be doing a lot of offers, Diwali offers, New Year offers, as well as Christmas offers. For all these offers, you need to keep adding some more coding features or adding some sort of, I would say, software updates that need to be done to make the offers visible to the general public. If you are not able to provide that particular update or offer in a specific time, then there's no use in doing that. For example, if they are doing it for Christmas and New Year, so you have to deliver it before Christmas and New Year. If you find a fault at the end phase, it's gone case. So you'll be taking another 1 week to basically analyze it, solve it, fix it, and then do a complete revision testing. Then it's going to be a nightmare for the customer you're working for. So that is why we are doing the SQA activities right from the beginning. Now we'll go to the next one. So what SQA can do? So basically, if you're saying I'm doing software quality assurance, this is a more or less in the technical level, where we say right from, if you see from the top-down approach, first is requirement coverage, then analyzing the requirement, then designing of your software, then implementation basically is nothing but coding. So coding of your stuff and then recoding as well as rework as well as, it may undergo multiple iterations, and then testing, and then finally it comes to the maintenance phase kind of thing. Each and every phase, what your SQA is good. For example, if there is a requirement, you have to do a requirement walkthrough. For doing a requirement walkthrough, you require a requirement checklist. So during this session, in each of these things, we'll cover you with all the checklist even which we use for requirement walkthrough, so that you'll be familiar with what is happening in the software industry. When someone comes and asks about you, this is a normal question, what is SDLC? I can say easily 4 or 5 phases are there, we'll do this. But your differentiator will be, in this requirement phase, I'm doing these things. These are the checklists I'm using. And these are the basically standards I'm following for these requirements. And this will be helping me to reduce the defects. If you talk this kind of language to any of your recruiter, then obviously your chances are really, really high. So that's what we want to get into details with the standard artifacts, as well as explain you the significance of why this is being used, and then at what circumstances it's also going to be used. Then analysis walkthrough, design walkthrough. Design walkthrough will be done by the group of people, architects, because one team will be developing and one team will be doing the walkthrough, saying that whether they will have 5-6 factors. Whether it is a scalable architecture, for example, today we are using it for 500 people. If tomorrow if I want to scale up to 5,000 people, it is not only the resources. For example, today we have cloud. We can add any amount of RAM or a server. That doesn't help if your design is not proper. So they should ensure the design itself is scalable. The DB itself is scalable. The way they have, because in earlier days, they used to write plenty of stored procedures. Now that practice is gone because it is not much scalable. So you have to bring a component into as a light element, as a microservices within the system, so that this is much more scalable. So today the architecture design review will have a huge checklist, which will be, we also will provide the checklist and then try to explain you about that, saying that why we are using all these things together and what are the key inputs that we are capturing and why we are capturing that input. If we are not capturing it and if we are capturing it wrong, what are the what do you call the influence or the impact that is going to have on the future. So those things we will get into. Then code walkthrough. Code walkthrough is basically the standards. Okay, there are certain coding standards which are available. So the first thing the audit team will check is whether you have written the code as per the standards. Then comes whether you have written it right or wrong. First, we have to write it as per the standards, the standard naming conventions, the standard nomenclatures, standard commenting procedures. All these things are called as standards. So audit teams has different agendas. They check the standards, they will check the coding, and then the testing team will check whether you have done it at the unit level as well as in the larger level kind of thing. So these things we will cover in a very detailed way. And then coming into an elements of SQA, as you told, to reiterate, standards, your reviews and audits, testing, defect collection analysis. The analysis of defect is very much important. Then change management. For example, if there is a change that is required in the requirement, so change can come to different things. One is they want to reduce the cost. Again, there is a change. They want to scale the functionality of the application. Again, there is a change. There is a restriction in using some kind of technology in that. For example, I have seen that personally in some sort of reports. So the requirements will clearly say we need to develop that reports, but the reports will not support the technology you're doing. So again, there need to be a change. So change management is a very, very critical process in the software development life cycle, which we will also deal in detail. Then education. This education, nothing but training. So the people who are working, especially in the project, they need to be trained in the particular domain or a particular feature or functionality that the training department will take care of. Then comes the project management of SQA. Because vendor management, security management, safety, risk management, mostly will be handled by the project managers, where to say that, so you need to keep the vendors happy or the customers happy is one thing. The second thing is, as per the committed requirement, we should be able to deliver in time as well as in quality. The third thing is security management. So we need to ensure all types of testing have been done, especially in terms of performance as well as security, if it's going to be any sort of application together. Then safety and risk management. This is more or less, safety is disaster and management, because they have, for example, if you are storing the code in a specific place and so DRC. So that building has some problem, suddenly it collapses or something, then where will your data go? Because it's more or less on the data safety and then how you mitigate the risk, whether you're taking daily backups and then tape kind of backups, so that all of the work that you have developed can be restored at any point of time. If one geography fails, whether other geography can sustain the deliverance of the particular product. All these things will be handled in the risk management as all these plan formats for you, so that they can understand how much effort is going into this kind of act. We spend around 35% of the effort on the basically on the quality side of it. Then we have a testing overview, and we have one more. What is in the next session? So what I will do is I will cover the software testing overview and then start with the standards and metrics and assessment for you. As I told you in the beginning, the format will be after this. The floor is open for you. Now I will open the floor for the testing. So thank you guys. So now the floor is open for testing, so that you can ask, and then if there is any change required in this session, or I would say that we can discuss and make the accordingly change. Now the floor is open to you. All the students. I hope all the participants are unmuted so that they can come out. Any specific questions and expectations from the sessions?
Happy birthday.
So basically, the session was muted for the participants, so that anybody is having a question can raise their hand, so that we can open it for their. Yeah, that's what it is. So that it becomes easy for answering and for the clarity of others also. Rather I would ask you in a different way that is there any specific expectation from your side on this session? Because there is a lot of activities as well as opportunities coming in this area of software testing, and then by seeing the trend, plenty of work will come to India for doing software testing from corporates. Do you have any specific questions regarding the this area? And then basically any specific expectations from your side? I got one question. So how much will be the starting package for a fresher in this field? It's more or less in line with what a developer will get. So there is no initial discrimination between tester or developer when you are observed into a company. So usually it will be around 3 lakhs if it's going to be a standard company, and if it's going to be a very small startup company, at least you will get some 2 lakhs definitely. It should be basically useful for any field, because when companies are recruiting, they don't clearly earmark in which field you are coming from, but they see what you are capable of, how well you can communicate or translate that into testing kind of thing. So I don't think that will be an issue in that. Could you tell in detail about SQA activities payoffs? See, initially, when you are observed as a trainee engineer, the starting package will be the same. So there will not be any major difference between your developer or tester, a person who has taken into SQA kind of stuff. There will not be any change. But when you grow up in the ladder, maybe 2-3 years later, depending upon your performance, you can attain very high positions, or if your salary package can increase depending upon the value that you are adding to the institution or the organization. Strictly implementing the process and providing timely reports to the development test teams, and then they find value. Obviously, you are doing the performance appraisals, your percentage increase. Normally today, the increase in percentage is up to 13 to 14%. So it starts from A, B, C, D kind of thing. So A will be around 3-4%, then B, the maximum performer will get around maximum 15%. That's the industry standard today, apart from some extraordinary cases. So depending upon your performance, your salary will increase. Okay, should we get on hands-on sessions like in college or in a webinar? So what we are trying to do here is, once in the part of the session itself, we will arrange some roundtables where students can also participate in that, so that we can do a roundtable session with 10 students, 15 students together who are participating, so that that knowledge will be available for all the other students too. Anyway, we have assessments on a regular basis. If you keep solving those assessments, then obviously you will have a better knowledge about what is happening in software testing and what are the things you should do as a software tester. Definitely it will help. What would be the prerequisites to required to attend the session? No, I don't think there is any prerequisites required. So basically, most of you should be the circuit branches, because the reason why I am putting circuit branches is the companies are basically insisting to take circuit branches. So I think they should be fine. There are no prerequisites except your interest level. That's a main requisite which is required here. And as a whole, I also wanted to ask that do you guys need some training materials? For example, we'll be having assessment and questions related to that. So we will also upload all the training materials in this respective area in your account. You can just go to your SelectSmart account. In your area of that particular activity, you will have all the details available, including the learning materials as well as your assessment questions. Do you think testers has more on-site opportunities than developers? In my experience, that is true. Testers has more on-site opportunities than developers. That is true. Because it may not be a long-term opportunity, but most of the people has to travel because of the whenever they do the business acceptance testing, because business acceptance testing will always be carried out by the customer. So when they are doing it at their own place, they want the support from the testing team to assist them in doing the testing. So obviously, people will travel, and then maybe for 1 month, 20 days, or even 2 months, 3 months. So those things will definitely happen. What is the growth rate in this field? What do you mean by growth rate? So how fast you can grow up in the ladder? It purely depends upon your talent as well as your attitude and your hard work. So there is nothing, there can nothing be stopping you from growing faster if you are putting your 100%, and then if you are working very smartly. So the key attributes I would say for your faster growth is your attitude and then your effort. These two are the very, very critical things apart from your talent. So if you have all the three, definitely there's no one is going to stop you. What are the most important aspect of our product that makes us unique while testing? I could not understand this question. Aspects of our product, things that makes us unique while testing. Aspects of our product. If I read it correctly, aspects of ourselves, if I take it as ourselves rather than product, the uniqueness in testing is the more attention to details. What you are putting while testing is what is going to give quality bugs, because the efficiency of the tester is being identified. It means the type of bugs he is finding out, whether he is finding critical bugs, whether he is finding the right bugs. Because if you report a wrong bug, that's a rework for all the development team and the other teams. Finally, they'll come and figure out your testing is wrong, so that they have spent so much of effort in analyzing this and then doing some extra effort and doing something for that. So the quality of the defect, what you are raising, is very important. And for that, your attention to detail and understanding of the requirement is very key. If you are having an excellent understanding of the requirement or about the product, and if you are putting a lot of attention to details and then trying to narrate it very clearly, that would make you a unique testing area. Sir, as in interviews, they are most focused on manual testing rather than other testing. What brings it important? However, it should be equipped with this rather than other things such as SAM and all. This is the fundamental thing. That's what I was talking in the beginning also. Whenever you go for any interview, people try to forget the basics, then understanding the high level things like your automation, Selenium kind of thing. So what they expect is how well you can analyze and understand the requirement so that you can apply purely your common sense, then identify multiple scenarios. What will happen if we do this? What will happen if customer does that? So what happens if customer does it wrongly? So you have to think all the possibilities and then put them all as test cases. So the fundamental and basic things is how well you are putting your test cases, test the application, how fast, and then how well you have understood the requirement is very key. So that's why what you call they're more focused on your basics understanding of manual testing, because without manual testing we cannot move to automation. Because when you want to move to automation, we should know what is the amount of effort that takes to manage testing, which are the areas repeatable defects and bugs are coming. So only those areas where repeatable features are coming, as well as more amount of bugs are coming, they're going for automation. So to do that, you need to have wonderful knowledge or understanding, and then you should be able to think in multiple facets so that you can bring out the various scenarios which will be done by the customer. For example, if you are using any banking application or any search application in online today, everyone will do it on their own way. So everyone will not follow the process. Some will click here, some will click at the end. So there are multiple ways people will start using that. So if you are able to simulate, or if you are able to think the multiple ways people start using, that makes you a very good tester. Okay. What are the coding language we'll get to auto modify this course? So mostly the coding languages used are Java, JavaScript, and Python. So these are the three things. Python is mostly for automation. Java and JavaScript are used for automation. For manual testing, you don't need any coding thing. All you need is more or less common sense. That's it. Are there any risks you think we should be specifically aware of? Risk in our technology risk, product while testing and stuff like that. So we are doing the testing to identify the risks. Basically, that's the purpose of doing the testing itself. Are there any risks you think we should be specifically aware of? Risk in our technology. So every technology has its own plus and minuses. Some technology will be useful for this, and some technology will not be useful for this. So depending upon the way it is going to get used, we have to choose the technology, and there is no risk, I would say, in any technology. We should understand the technology and then see whether it is fitting to our needs. That's what company does during the requirement analysis phase. They will check whether this technology is going to help us take us through the journey of the product plan, kind of thing. If you do that, then obviously the risk will get mitigated. So if there are no more questions, then basically we can close this session, and then you can basically communicate with, if you have any questions, the mail that is provided, and also you can go to your page which is in the Select Smart, and then put your comment, feedback, or whatever it is, so that we look into that and then get back to you. But please take it seriously and then do the sessions as the assessment, so that it will help you a lot in the long run. So in multiple ways to understand the overall SQA and the software testing, as well as to be a complementary thing for the various automation things what you're going to learn in Selenium. So that's very, very helpful. I'm also aware that the interest levels in software testing may not be high at this point of time, but when you end up in a job, around 30% of the people will automatically be routed to the software testing work in any company when you join. So it is also good to be prepared for that, and we should not be missing any opportunity that is coming our way. And the primary question that what will have is, if you are becoming a software tester, will you not be able to development? You can do development when you enter as a software tester also. There are lateral programs which are available in companies where it can translate you from tester to developer, or even developer to tester. Those opportunities are also available. Okay, thank you guys. We'll meet in the next session. Thank you.